Good morning to everyone. Now we can see the topic commercially available FPGAs. So generally we have these are all the vendors are present: Xilinx, Actel, Altera, Plessy, plus AMD, Advanced Micro Devices, Quicklogic, Algotronix, Concurrent, and Crosspoint. So these are all the commercially available FPGAs. So what are all the architecture used for each and every vendors, logic block, and the programming technology used. So the table shows that there are four types of architectures are present: symmetrical array, row-based array, hierarchical PLD, programmable logic devices, key of gates. So these four FPGA architectures are used for different types of vendors for depending upon the applications. Then the logic block types, the logic expression can be used in either in lookup table type or multiplexer based, programmable logic device based, and NAND gate. So these are all the four types of logic block used by different vendors. Then the programming technology is nothing but making the connections between logic block with the resources, input, output. So for that, static RAM, anti-fuse, EEPROM, these are all the three programming technologies used to program and make the connections, logic type, and the resources. So the previous slide, we have seen many vendors. Here, the one is Plessy logic block. So the Plessy FPGA is called an electrically reconfigurable array. It uses static RAM programming technology and consists of a regular two-dimensional array of logic blocks overlaid with dense interconnect resource. It is relatively simple, containing an 8 to 2 multiplexer that feeds a NAND gate and a transparent latch. The multiplexer is controlled by a static RAM block is used to connect the logic block to the routing resources, which comprise wiring segments of various lengths. Local interconnect for both short connections and local range connections for moderate connections and long range interconnected short range. So all these things is established. So this is about Plessy logic block. The next one, plus logic functional block. So this is one of the vendor fabricating the FPGA. So the plus logic block, uh, the plus logic FPGA consists of two columns. One is AND array, the another one is OR array. Okay, that can be fully interconnected by a universal interconnect matrix. The logic capacity of plus FPGA, which uses the EEPROM programming technology, it has 2000 to 4000 equivalent gates. So it has the functional block, and it has a output cell. Okay, so you will get the FPGA outputs here. So this is the total universal interconnection matrix. So the next one is advanced micro devices FPGA. So the advanced micro devices FPGA consists of, based on the EEPROM technology, it can be considered to be an array of PAL devices that are interconnected by a switch matrix similar to an Altera FPGA. The logic capacity of this FPGA varies from 2 to 8 PAL blocks or 9000 to 3600 equivalent gates. Each PAL block consists of 3 main pods: AND plane, logic allocator, and macro cell. So this is about advanced micro devices. The next one, Quicklogic FPGA. So this is the logic diagram. It consists of, okay, that is 6 input NAND gate and two input, that is AND gates are present. Similarly, the AND logic. Then you have a multiplexers and the flip-flop. So the quick logic FPGA consists of a regular two-dimensional array of blocks called P-ASIC logic blocks. The logic capacities of the first generation of Quicklogic FPGA is between 48 and 38 PLDs, or 500 to 4000 equivalent MP, that is GA gates. It comprises of 4 2-input AND gates feeding two 2-input multiplexers which feeds a third multiplexer. The first two-stage multiplexer select lines are driven by 6-input AND gate, and the second stage multiplexer select line is driven by another 6-input AND gate. The second stage multiplexer provide there is a clock which can be optionally used to do the D-register clock. So this is about Quicklogic FPGA. Then the next one is Algotronix function unit. It has the Algotronix FPGA is organized as 32 into 32 array of configurable blocks. Each block can only be directly connected to 4 neighbors, left, right, above, below. But longer connections can be formed by routing signals through blocks. The Algotronix FPGA uses the static RAM program technology, implementing connections with multiplexers. The devices have a large capacity of 1024 programmable blocks or 5000 equivalent gates. So the configurable logic block comprises of several multiplexers that drive a function unit. The function unit is capable of implementing any logic function of its x1 and x2 inputs, or it can be alternatively be configured as a D batch. The next one, concurrent logic FPGA. So the concurrent logic is nothing but you have a parallel connections of many architectures are present. The structure of the concurrent logic block comprises user configurable multiplexer, basic gates, and D flip-flop. The concurrent FPGA is especially well suited for register intensive and arithmetic applications, since the logic block can easily implement an op-order and a register bit. There are two direct connections between each logic block and its 4 neighbors. Longer connections can be formed by routing signals through the multiplexers within the blocks. So it is based on two-dimensional array of identical blocks where each block is symmetrically its 4 sides. So the array holds 313 and 313. The next one, Crosspoint solutions FPGA. The architecture consists of rows of transistor pairs where the rows are separated by horizontal wiring segments. Vertical wiring segments are also available for connections among the rows. Each transistor row comprises 2 lines of series connected transistors, with one line being NMOS and the other PMOS. The wiring resources allow individual transistor pairs to be interconnected to implement CMOS logic gates. The programming technology is used is the anti-fuse technologies. So this is nothing but it row wise there are transistors are connected. So this is nothing but Crosspoint solutions FPGA. So these are all the commercially available FPGA, and we have discussed what is the configurable logic blocks of each and every one and how the routing connections is obtained each and every architectures. Thank you.